Okay, last day of the show and almost the last session today. So, guys, are you ready? Yeah, good morning. My name is Amy Chen, Business Development Team Lead of the Open Infra team from QCT. So QCT is the subsidiary of Quanta Computer, and we are the global data center enabler and the solution provider. So I'm also taking care of the solution product, including but not limited to the NFVI that we are going to share today.
Hi, morning everyone. My name is Marco. I'm the technical lead taking care of the open infrastructure, and my teams focus on the NFV infrastructures and to provide the best fit for the telecom business.
So in the following 20 minutes, we want to make sure we get across two simple messages to you today. One thing is that echoing what this summit has trying to deliver to all of you, that NFV is an inevitable evolution recently, and the NFVI is the key foundation. And the second thing is that QCT has been devoted to collaborate with the ecosystem, including the strategic partner like Red Hat and Intel, as well as the open community like OpenNV, to provide a well-validated and fully optimized infrastructure to the carriers. So I want to start from some challenge we learned from the network operators. So you know that new generation services are emerging, and that requires enhanced network performance and architecture. Secondly is that today's new deployments and capacity upgrades are so huge. So how to deploy in a very fast and efficient way is a problem. And last, the most painful to the customers and those communication service provider must be the single purpose appliance from the proprietary. So they are looking for a unified and open infrastructure to serve for multiple workloads. So these are also what we try to solve when designing the NFVI infrastructure to the customers. So as you might know, there isn't any standardized benchmark tool for the NFVI. You think of Rally and Tempest when using OpenStack, and you use CBT for safe. Then what's first NFVI? So here, we leverage the OpenNV YardStick ecosystem and the TRex to customize our own test suites and test cases to do all the validations. And then other values I would like to highlight would be like high availability, scalability, and the openness. Another thing I would like to point out is the EPA enablement, that we selectively select and enable some EPA features inside to improve the overall network performance. Later on, we will also share more details. So here, this one is a really typical ETSI architecture, and this also perfectly outlines the NFVI scope that we are sharing here. From the very bottom layer, you can see that we use the QCT latest Perly platform as the foundation. And then on top of it, we use the Red Hat OpenStack as the virtualization layer. We not just simply integrate the software and the hardware together, there's something more inside. For example, the selected EPA features can fully take advantage of the QCT NUMA balanced design hardware. So I'll let Marco share more details inside.
Okay, so on this slide is our offering in QCT NFVI offerings. So there's on the left-hand side of the slides, we have the couple or more combinations for the overall clusters. Definitely that's one of the infra nodes, which is we have all the deployers and the monitoring inside the infra nodes. And the following down below will come with the 3 controllers for higher abilities. And the number of the compute nodes pair with the DPDK SROVs, and also we use the Ceph as a backend storage. That's the architecture we designed based on the Red Hat OSP product. And so on the right-hand side, I'll tell you more ingredients we put into the all architectures. The first one will be that we cooperate with Intel to do the hardware level tunings. So think about how many parameters inside the BIOS, like a bunch of those, and how we're gonna make it right. How we're gonna make it do the right numbers to fit into with your softwares. That's the key. So spend like a couple months try to do the back and forth A/B test to try to find the best parameters. And for the data plan collaborations, what's the memory bandwidth? What's your latencies on your motherboards? What's the latencies? So we leverage your MLC and the benchmark tools to try to see if the memory on the right channels. And for the QAT, what's the encryptions? And for I/O performance, what's the disk performance? That's the things we spend most of the efforts with the Intel try to find the best known configurations. As for the Red Hats, we enable the EPA features and the sROV and DBDK. And that's the key because the kind of features totally leverage on your hardwares. If your hardware with the Luma balance optimizations, your traffic can really leverage your PCI travel to one of to dedicate sockets and back and forth to increase the throughput and lower down the latencies. So the Luma balance design can allow you some of the EPA feature can reach the maximum performance. So the last one is how you're gonna validate the certain ingredients, how you're gonna validate your clusters. Just like you got a car and how you wanna know how fast your car can drive the mile per hours. So we leverage the YardStick testing ecosystem in OpenNFV. So there's a couple of the upstream scripting scenario, so we modify and we do a lot of changes to close to reality and fit into the Red Hat OSP product. So we use the OpenNFV YardStick testing ecosystem against your clusters and see how fast the readiness of your entire platforms. So that's the overall architecture we're gonna offer from the QCT. So next slide, I'm gonna give to Amy how we're gonna build a well-validated NFVI OpenStack.
Right, so actually to build a well-validated and fully function NFVI from scratch, it really takes time. So from logical and physical network config and to develop and build your infrastructure, and finally to verify to make sure it's ready for up and running from scratch. It would literally maybe take you more than 10 weeks if no experience. That's also why that we develop an auto deployment tool for you to eliminate all of these suffers and efforts. So I would like to give Marco some time to elaborate how we're gonna do in this tool.
Okay, so here is the key. Here is the differentiation between we and others. We have the tools. Now how you gonna have we call it the zero touch. So how you gonna run your deployment from the hardware level all the way to the solution ready? So the first step, though, there's two sections inside these tools. One is we call it the hardware collectors. So you can collect all the hardware informations by to put into the configuration file or either the database. So that's the key because think about how much you're gonna spend to configure your BIOS. You want to do the RAID, you're going to do the boot orders, you want to do the NIC orders, and you want to do the UEFI or legacy modes. That's taking you really a huge amount of times. If you got a whole rack, think about how long you're going to take. So the tools we develop ourselves can run all the cluster BIOS configuration simultaneously. So think about like 42 servers in a rack. So if you do one each offline, so it probably take a couple hours, but with the tools, you can really minimize the time you spend on the BIOS configurations. And once we have all the configuration ready, we put into our database. And the database will store all the information you require for the solution deployments. So then later on, the next step, the solution deployment will kick it in and try to attract all the information from the database and start running the solution deployments. So that's it's just a one touch. you don't need to, of course, you have to provide all the prerequisites based on your environment. So we can, then we fit into the deployers, fit into our tools, so they can just one click and you can hold your cluster up and running in certain amount of times. Really can shorten your process. And also one of the benefit is how you're gonna duplicate the whole cluster into the other environments. If you are SI and you have one deploy for 8 companies and you want the same scale on the big companies, if you want to do it by handcraft all your environment, it will take so much time. And without errors. If with the errors, your environment will totally different. So the tools can make you like, you can duplicate your environment from A to B and to C and to D. So that will save some time for the system integrators and also for the customer too. So that's the key, that's the differentiations that we brought into the market. So next slide, I'm gonna give you some testing results. So Amy will give you some briefing.
Here comes the most interesting part is the testing result. So we got a couple of the scenarios. The first scenario that we would like to share with you is the traffic between 2 VMs. Actually, it's a east-west traffic, and we validated by the YardStick ecosystem, which you just mentioned.
So right here, you can see the differentiation between the SRV and DPDK and enable or without enables. And so on the slide right here, you can see with the DPDK enable, obvious DPDK enable, you can get approximately 6% on the overall performance. On the far right-hand side, that's the comparison between the generic OpenStack and with the SRV DPDK enablement. So you can see the SRV is one of the maximum performance you can reach. If your workloads really rely on the SRV, you can get the maximum performance.
Yeah.
So for the next slides, we're gonna do for the north-south traffic. For the north-south traffic, you can see we still do the same, pretty much the same. We just want to compare the SRV and DPDK enable. Because customer really like to see what's the benefit we can have, what's the performance we can get after EPA feature enables. Here is the result. So with the DPDK, obvious DPDK enables, you approximately like 39% enable, 39% improvements. And on the far right side, and you can see the SRV is still one of the best performance. So, but here we just not want to tell you which SRV DK, which one is the most benefit or the best, but just really depend on the workloads and depend on the scenario you're gonna apply on your environments. So here is just a result for your reference. So here tell you the EPA is the key for the overall performance. So I will hand over to Amy to close these sections.
Right, so we're probably gonna end our presentation here. So if you are interested in detailed findings in terms of those data and results, feel free to come to us afterwards or stop by our booth right behind you, QCT's booth. So thank you for your participation and enjoy the rest of the day in Vancouver. Thank you.
Thank you.